Welcome to Have You Heard, where we talk about issues at the intersection of agriculture and engineering. Let's get started. Here are your hosts, Morgan Hayes and Josh Jackson.
Welcome. This is the Have You Heard podcast. This is episode 55. We're going to talk today about equine footing. I'm Morgan Hayes, an assistant professor in Biosystems and Ag Engineering here at the University of Kentucky, focusing on livestock facilities. And in my personal life, I farm in Boyle County, Kentucky with my husband, about a 500-acre commercial cattle and hay operation.
And I'm Josh Jackson, and I focus on precision livestock farming here in the Biosystems and Agriculture Engineering Department as well. And at my home life, I focus on raising goats and cattle.
Okay, registered Angus cattle, Josh.
Registered Angus
I don't want to sell you short at all. We have a special guest with us today, and that's Staci McGill, a recent PhD graduate and my graduate student. And Staci also farms, so introduce yourself briefly here.
Hi, I am Staci McGill. I am, Dr. Hayes said, a recent PhD graduate. I do farm here in central Kentucky, but I raise horses instead of cattle and goats. So I have a small breeding and sport horse.
Staci. So our topic today, and the reason you're joining us, is equine footing. It is Derby week, which is highly entertaining in the state. A high dollar, actually,
Yes.
input state to the state overall. I mean, it's a big part of our industry here, so it's an important thing to acknowledge. And equine footing was a big part of your PhD work. Specifically, we talked about arenas, not tracks, but we're going to talk about footing in general and some of the characteristics of it. But before we do that, we're going to do what's been happening on the farms this week. I'm going to let Josh go first. I'll go, and then we'll let you go last to give you a little bit of prep time.
Sounds good.
So what happened on the farm this week was we actually worked on our gearbox and actually got our gearbox put back together. And so it's back on one of our mowers, so we're really happy about that. And so we just have one more mower to work on, and then we'll be ready to go cut hay, I think. So we're definitely getting a lot closer than we were.
We have a tractor that's getting put back together, a truck that is now functional that will be used to haul hay here shortly. We're still working on cleaning up a couple pieces of equipment, but everything looks to be operational at this point. We moved cattle this week to the back. Cows with calves, our calving group to the back of the farm, which we've avoided doing just because if there's animals that need to get up, because of calving difficulty, it's a lot harder from the back. We've got one cow left. So that's pretty good progress. One cow, one heifer left. In fact, we went to move them yesterday thinking there were two cows left to calve, and everything went back except one of the cows that hadn't calved. And I said, oh, there is a calf with her. She just had it hidden. So a life lesson, check much more closely on those two cows before you move everything to the back, because it was not a particularly smooth move.
Oh, yeah. Probably not too happy about trying to.
Well, she actually went pretty well. We just picked up the calf and kind of took it up towards the gate, and she carried it back. She knew where the group went. The calves that were about 3 weeks old were a different story. So
Pandemonium, probably the story.
it was a little bit of pandemonium. But we kept them moving. We also processed some steers a few weeks ago, and so that meat came in this week, so we had to get all of that settled out. Lots of little details logistically to get everything sort of squared away. So lots happening this week.
So then I guess it's me. So this week on our farm, we had some damage in that early March windstorm. And so I finally have a complete roof on my barn now, which is really exciting. I was down at least one stall that was making things very interesting for moving horses around. And so that's been the big thing. And then we have started mowing pastures and paddocks. Always a fun endeavor to get all of grass mowed. Unfortunately, because we have a lot of small areas, get it done very easily and quickly. That's what's been happening.
Sounds about like any other farm, a lot of work and a lot of rewards some days.
Yes. Yes.
So our topic today is equine footing, and we're going to lean heavily on Staci here to answer questions. I know a little bit because I've been working with Staci, but she's our resident expert. So I'm going to let Josh ask the first question.
So, with the Derby coming up here, and I heard about 2 horses going down potentially, and so footing is a big deal. I guess the footing and actively engaging, that's their engagement point for the track. So for the sport horses, like what are you looking for? I know sand, like the mixture of sand, there's different types of sand. There's little nuances that are very, very important to these tracks.
There are. So there is a discussion about how the difference between how a racehorse interacts with the track versus how some of the other disciplines interact with the footing surface. So when we think about a racehorse, there's a lot of movement laterally forward as that gallop is trying to get as quickly across the footing as possible. When we move into some of the other disciplines, it becomes a much more vertical interaction with some of the surface because of potentially landing from jumps, some of the dressage movements that are, we would consider them lateral movement, but that really involve interacting with the spot. When we move into some of the cattle discipline or the cow horse disciplines, we also have some differences that happen. Some lateral movement with reining, with sliding stops. So depending on what the focus is for the competition or event or training surface, we have different things that we want to have happen with that surface to help facilitate that interaction with.
Okay, and so for that, for us as engineers, the structure of that is going to be important. What additives are important for, I guess, the functionality of the surface, like for providing a solid surface for the horse, but also that springiness potentially?
So depending on what discipline you're looking at, that could actually be clay. It could be something like wood chip that are more organic or naturally occurring in nature. When we move into some of the sport horse jumping, that type of thing, we're looking at fiber or rubber. But depending on what is in the footing and what you're adding to typically a mostly sand surface, will indicate the particle size distribution that you're. So we want a footing that typically has a lot of different size particles in it so that you increase the shear strength so that you have a footing that is good, solid. But the one thing that no matter what type of footing, what you're adding to it or whatnot, water becomes one of our biggest components in ensuring a proper surface.
So what happens if I overwater? What happens if I overwater a footing, sir?
It becomes a muddy mess.
Simplistically, okay.
The short answer is it becomes really wet and muddy, and we have sand sticking to everything and everybody, which is not what we want to have happen. But you can actually create a surface that has too much slip in it and can become mildly dangerous if it has too much water in it. For most of our footing and commercial footings that we have, that amount of water has to be incredibly high in order for it to start to get a little slick and a little dangerous. Obviously, that's a little different grass versus sand footing.
Right.
But overwatering, the biggest issue and most noticeable issue immediately is sand sticking to.
And I would say, like, for people that are not familiar with footing, it's very much like the beach, right?
Yes.
There's going to be the dry sand that you walk through first, where the particles move everywhere because there's no structure to them. They have the ability to move around freely. They're small particles, and there's no real stickiness to sand. And then you get to the really hard sand. This is like the layer where people like to run if they run on the beach. It's good and solid. And that's where water comes in, but it's not like continuously hitting that area. And that gives you that structure that you want. And then you move even closer to the ocean, and the sand starts to go around your foot and it absorbs your foot. And it's literally too soft. You have too much water, and those particles actually flow. The particles of sand flow around with the water molecules, and they move wherever they want. So that's that slip that she's describing. So it's really a very interesting dynamic and very easy to relate to something a lot of people experience.
And so on the opposite end, if we're too dry, what's our big concern if we're too dry in the indoor arena, especially?
So much like Dr. Hayes said, when you get too dry, the particles don't form any solid base. So a horse's hoof is going to be sinking really deeply into that surface, which we don't want. Most of the surfaces we've encountered throughout our research, that it's only that top about half an inch to an inch that really has any play into it. And so if you start to get too deep, much like trying to walk in that deep sand portion of the beach, you can start to have some soft tissue injuries and other types of injuries if you really push through working in that type of a it just is, there's no support there for the horses, and they'll do it, but they will struggle.
Yeah, and I think some of the disciplines allow for a little bit more absorption of the hoof, and other ones want a lot less. And it's really a discipline-specific desire. But there is targets that are out there for like actually hitting the right amount of moisture for different types of footing.
Yes. So one of the aspects that we really look at is what is known as the bulk density. So that is the basically maximum amount of water that a typically soil, or in our case footing, can absorb and really handle. And so that is typically our target moisture content to ensure that we maximize the properties of the foot, your strength and other things, but also minimize the potential wear and tear on the horses and kind of provide the best for them.
I'm assuming I'm not a horse person, but so if I wanted absorption, maybe the jumping one, I want extra absorption for those, or who needs the most absorption from an impact standpoint? The jumpers, or
that depends. A lot of the research that's been done has actually indicated that some of the have higher amounts of impact on the surfaces. I think when we start to get up to the higher levels of jumping off of pretty big fences, that is a substantial amount of force coming down. The important thing to remember, especially when we talk about the jumpers, is you want that grip and that solidness, but there has to be a little bit of slip to the footing, because the horse does not land straight vertically. There's a little bit of a horizontal slide that has to happen. And so you can actually get footing that is too whippy, and can cause just as many issues as if there was too much slip to it.
Okay. And you mentioned the sand, but there's different types of sand. So there's a river sand, there's different types of sand. Would you want to kind of just briefly describe some of the types that you're familiar with?
We have encountered a wide variety of sand. And if anybody just thinks sand, it is not. Depending on what you're looking for, river sand is a very common type of sand to see. Also because it's priced at a point where people can afford it. Yeah. And that is a huge consideration. You want to provide a footing you can afford and that is stable. As you start to get to some of your higher end sand, we actually have glass manufacturers that sell sand. And so you get a really clean sand, but it's also very expensive. And so that is something we have seen. Different types of sand tend to have different vertical size ranges. We've had some very interesting exposures that have introduced us to like cave sand, which apparently is a type of sand people like to use. And a lot of different, and part of it also depends on what quarry you're getting it from as well. And each quarry has different types of information about their sand.
Yeah, and even within quarries, there can be variability. It just depends on where, if it's being mined, it's coming from within a rock formation. So I think one of the things that's really interesting is there's different hardnesses to rocks, right? So the glass manufacturers use a lot of silica sands, which are known to be a very strong, hard substance, a lot less breakdown of the material. Coming all the way down here to here in central Kentucky, we have a lot of limestone. And so we have a product that's called ag sand, but ag sand is really crushed limestone material. That would not be something you'd want to use because it'd be very dusty. It would break down very quickly into very small particles, but certainly something to keep in mind. As you're choosing a material, you also want to understand what sort of that base rock is in there, because there's different hardnesses to rocks, and it plays a role in how the longevity is going to be on that footing.
And so we talked about, you mentioned longevity. So if we have those rubber products that you put in that footing, like how long do those last? Are they going to be resilient for a number of years, a couple of years? Like, what are we looking at as far as longevity?
Typically, I would say that you're going to get at least a few years out of it. In a lot of cases, people are replenishing sometimes every year, sometimes every 3 or 5 years. Depending on the facility, they may actually pick the hooves before they leave the arena to help preserve and keep some of that sand and that expensive footing in the arena rather than having it leave. There's an interesting term that sometimes gets used to describe footing, in that it's dead footing. And so it has lost a lot of the parameters and the things that you would want for it to be an interactive surface, which it is a little weird to talk about an inanimate object as being dead. But the biggest thing with that is replenishing, and it may not be pulling everything out of the arena, but just kind of augmenting so that you're adding in, so that you're not having that big expense all at once.
And so we augment, help it sustain this. But what tillage tools? So I think you tested some tillage tools as far as what were you looking for, and trying to figure out what worked, I guess, for you.
So some of that also depends on the discipline, and it really depends on what you have in the footing. So if you have fiber or rubber in it, your footing, your drag is really going to have a conditioning wheel on it, and that conditioning wheel helps continue to mix and keep that fiber in the footing itself. If you don't make sure that that fiber gets reduced, it starts to actually float on the surface and will separate out from the sand. When you start to get to even the straight sands, you do want to make sure that you have a proper drag to help keep it, keep not only the top surface looking and working the way you want, but some of it is also ensuring that what some people refer to as the hard pan, so that's a few inches down, stays the way and stays smooth and stays even. All of that said, your chain link fence with a couple of cinder blocks on it does not count for keeping your footing in decent condition.
It might work with just sand if it's not that dry or that wet.
Yes. And you're not doing something on it that potentially is impacting that surface a couple of inches deep. But when you start to get into things that are potentially really impacting that surface, you want something that works that top couple of inches, but doesn't create too deep of a surface that the horse is kind of stuck down in it.
Okay, so not having to really work hard, but still functional.
Yes.
Okay. And so, for testing that ideal moisture, you said bulk density. Is that a lot of times, is that something easy for producers to figure out? Is it hard? I mean, it seems like there'd be some difficulties.
Unfortunately, that's not the easiest thing to determine outside of a lab setting. But what we can determine, and depending on the type of footing you are adding fiber to it, the fiber company may actually give you a target moisture content that they think is a good moisture content to maintain. Typically, it's anywhere between 9% and 16% by mass. There's unfortunately two ways you can determine moisture content. You can determine it by volume, or you can determine it by mass.
Yep.
A lot of times it will give a reference on a volumetric basis, which will further confuse someone trying to manage a footing.
Yes. Right. So typically it's, as I said, it's between that 9 and 16% that we've seen, and anywhere up to 20%. Based off of the general type of footing, we could give you a pretty good estimate about a target moisture content that would work for the footing.
We're working on a calculator to help a producer actually calculate the water that they need to add for a certain dimension arena with the moisture content maybe tested in a microwave or a simple test like
Okay.
that. So that's one thing we are working on this summer, is to produce an actual calculator to make that process a little bit simpler for a producer, a farmer, manager, horse owner.
I know because there's similar microwave tools for estimating, I guess, your moisture content for your hay.
Exactly.
So
For
that-
hay or forage, a similar concept to do the same thing with footing.
And so, we're thinking about maybe the race horses again. So not
Yes.
shifting gears too awful much, but thinking about the impact there. So you test the impact of a simulated impact of a horse hoof on these surfaces. Like what were we able to see from that?
So we can not only see that the force that they're hitting and impacting the surface, but we do get a rebound force that we can see, and that will change with the actual moisture content of the footing. So we were able to actually see that as we increase that moisture content to the bulk density, we increase the strength of the footing and how that hoof interacts with it. And then when we push past that bulk density moisture content, so we get to 115.5% moisture, how it all also drops off. And what we really see is how that hoof and the amount of, and it's not just how the hoof rebounds, but it's the amount of energy that is moving up into the horse's leg, decreases and kind of hits its sweet spot at that bulk density. So that, and that's really what we're looking at, is that sweet spot between how much force is impacting the ground, but also how much force is then
Transferred back to allow for that traction.
And all of that research is from Dr. Mick Peterson's lab group here at the University of Kentucky. So they do quite a bit of track work, testing for tracks across the U.S., and they have developed this way of monitoring that strength of footing so that they can actually evaluate a track and see if there is any risks or dangers, and to help them do what they can to make it as safe as possible for horses on the tracks. And they do a tremendous work for the racing industry.
I think so. You're pretty much developing a standard almost.
They have ASTM standards. Yes. Yep.
Okay.
It is an ASTM standard, the way that they measure it.
And I was, listening to, we have some senior design presenters as well. So I know that the grass track can also be an issue on the grass, the turf tracks.
Yes, it does get more complicated when you add in grass arenas or tracks, because we do have grass arenas. One of our biggest show jumping shows in up in Canada, and it is on a grass jumping surface.
Okay.
It is an engineered surface, so I think that's one thing to notice. People sometimes see grass or turf and they don't know that they still work the same way on the design. They build a base, they create drainage layers, they put slopes on those materials so things move the way they need to. They measure the density, the bulk density of those materials, the moisture contents, the uniformity, they apply water, very similar to what we would do on a standard sand. They just have more variables because they have a living organism growing on it that they have to manage in addition to what is already a fairly complex system, which is, it's kind of crazy to think about.
And we actually saw that last weekend. So yes, we are in Kentucky Derby weekend, but last weekend was the Land Rover 3-day Kentucky event out at the Kentucky Horse Park here in Lexington. And so they highly manage the cross-country course there, and that starts even in the fall, that they start working on managing the track for that particular year to ensure that when the Kentucky 3-day event comes along in April, that track and that footing and that grass is at its optimum performance for when they start cross-country day on Saturday.
And it's amazing to me because, they also, I think for the tracks, they talk about putting dirt in the holes whenever they have the holes being made by the hooves. Yeah.
Yeah.
And so just making sure that that's a uniform surface across there that they have to maintain, I think, on a daily basis.
Yes.
I think it's every so many starts, right? Sometimes it's on a daily, sometimes it's multiple times within the day because they have to manage every so many starts to make sure they have a safe footing for the animals to travel over.
And that's really when we start to look at some of the big barrel racing competitions, They will drag a short drag every 5 runs. And then every 50, they will do a big drag that they'll go in and make sure that that hard pan is set. And then when they get into some the championship runs and some of those classes, they're working that footing every 3 barrel race runs. And so it's just incredible to watch. Yes, I have done it. Yes, it is fascinating to me to sit there and watch the tractors go. But they work very, very hard to ensure that every horse that goes out is experiencing the same surface. And the people who run and maintain the footing at some of the big barrel racing events are incredibly knowledgeable in not only their equipment, but the different types of footing they're encountering at all of the different locations, because that is one thing. There are companies that they travel from location to location, so they have to be familiar and know how to work each individual footing rather than just being knowledgeable at one location.
Yeah, I guess is there a home court advantage for some, like, oh, they did really good here, but they do not as well in other places just because of the footing? Is that a thing? I mean, I know for basketball, I always say the home court advantage is a thing. So
and we see it with tennis. Some people do well on a dirt or sand. Some people do well on a standard clay and a turf. Like there's different people do well on different.
And you see the same in with the horses, that and the people as well, that they prefer to work on certain types of footing or certain surfaces or at certain locations. And they will sometimes set their actual competition schedules based off of, oh, the footing is good at this location, or I've had really good success there, so I'm going back because my horse does well, versus some of the others that, oh, maybe that footing's a little sticky, and so this particular horse doesn't do well on it. It's the same way where, sometimes a horse just has to run on the turf to learn that they prefer to run on the turf, that they're just not a good dirt track horse.
okay. It's always interesting to see what the little dynamic for each competition. And
Yeah, I think the footing is a really interesting dynamic. It's particularly challenging. We've been working at it in an indoor environment where there's a little bit of control over the environment, but both the tracks and the outdoor arenas are fully susceptible not only to the animals running on them, but the weather conditions, the evaporation rates, the sun load, especially if you have a track where there's some shaded spots and some not shaded spots. A lot of management goes into keeping that moisture content uniform across the whole surface. And in this area, we struggle sometimes with our outdoor arenas with our precipitation level. I know a lot of the U.S. doesn't have this problem, but here in Kentucky, with our 70-inch rainfall years that we've had recently, we end up with wet outdoor arenas quite often, and that's actually quite dangerous because it has so much slip in there. It's less predictable how the hoof is going to react when it touches that really wet surface. So getting that drainage right is a challenge.
And there's a lot of events and competitions that don't stop just because it's raining. So last weekend at Land Rover Kentucky Free Day, and then this weekend with the Derby, as long as there's no thunder and lightning, they will continue. So, last weekend, I'm sure there were people on Thursday and Friday who were doing part of their test in the rain or part of it not in the rain, or they warmed up in the rain, and then by the time they got into the Rolex Arena, it was, not raining, and we'll probably see potentially some of the same tomorrow, though I think that weather is ever in flux as it is here in Kentucky.
And bring up a point, so the moisture can be a problem outdoors, but the dust, I think, is a concern for a lot of indoor facilities. Indoor arenas, the dust can be a huge concern. How much of that is how big of a problem is that?
I think that's still up for debate. And we're still learning and gaining a lot of information on that. Much of the research that has been done in the dust avenue. And we have had some publications and papers that have indicated we do see some dust levels get concerning levels, especially prolonged chronic type exposure. We do have a lot of ways that we manage it, and one of the biggest ways right now is water and the addition of moisture, which potentially causes some other complications for a facility where that water is going to evaporate, but is it going to be able to structure? Depends on how the structure is built. But dust is, according to some of the research we've done, the biggest concern for people in those types of facilities.
I think the ventilation's that's a whole nother topic right there, Stacy.
Yeah, we're just gonna like hint that Stacy's coming back in a few weeks, and we'll talk about ventilation and arena design in general, because that's the primary focus of her work. But for a week with Derby, we had to talk about footing. It was just such an interesting topic.
And it is an interesting topic. Unfortunately, I can't, give you just one quick sentence answer, because it varies so much within not only the city of Lexington of what different disciplines we see across the state, then if you were to zoom out to across the country. And, the way Keeneland or Churchill Downs is managed is going to be completely different than Santa Anita or Del Mar in California, compared to Saratoga or Belmont in New York, because climate is a huge aspect that has to be managed.
Yes.
I think that's a pretty good summary of footing. Let's go ahead and do a what's happening on the farm next week. These are our big goals, Stacy. So
Okay.
you can claim these things and not do them, and it's still okay. Because after 4 weeks, they just fall off of our to-do list if we don't get them done.
So pretty much we're just finalizing getting stuff ready for the upcoming hay season. So going through all of our equipment, making sure we have a backup plan, still thinking about, do we need another tractor? What do we got to do in that aspect? And then moving cows here, there, and doing some pregnancy testing on our fall group. The fall group pregnancy testing, and probably doing some just deworming and whatnot, I think, on our farm.
Yeah, we got weights on our calves that are weaned that are getting fed right now, but we'll have to make some decisions. I think right now we're planning to hold all those calves out. We'll have to adjust feeding rates to those animals, order some new feed for them, make sure they're still growing the way they need to if we're going to keep them through the summer. We have 2 cows left to calve. I'm really hoping the next time we record, we're at least down to 1 and maybe down to 0. We have about another 15 days, so 2 weeks. It could be 2 weeks, but hopefully we can close it out next week. That'd be really nice. The twice-a-day checks are getting a little bit old, and the majority of those calves are now in the back on wheat that's taller than the calves. So it's getting really difficult to do counts back there, and twice a day it's too much frustration for me at the moment. Aside from that, getting hay equipment ready. We will, if we get a 4-day window, we have some of our higher quality hays that we'll start taking.
I will continue mowing. Mowing is a big thing for us right now. And then I would really like to get my grass jump field, all my jumps back up and ready to go for the spring and summer season, now that really get some horses moving and back in training and riding.
Okay, I think with that, we'll end today's podcast. We'll be back with another podcast next week. And just to hint at it, we're going to steal Stacy back for one more talk about equine arenas, probably 2 weeks from now. And we will see you guys next week with another new podcast.
Thanks, everybody.
Have You Heard is a production of the University of Kentucky College of Agriculture, Food and Environment, along with the Department of Biosystems and Agricultural Engineering. Discover what's wildly possible at ca.uky.edu.